Welcome students. Actually today we are going to see about the topic called lead compensator. So already in the previous class we had a discussion on lag compensator as well as compensator design. We have completed, right? So now we are going to talking about lead compensator. What is lead compensator and why we are going for lead compensator? A compensator having the characteristics of lead network, which is called lead compensator. Not only that, even a sinusoidal input is applied, the phase will have a lead, that is phase lead. Sinusoidal in the sense it will be like this. So when we are applying this signal, the output response we have a phase lead. That is the reason why this is called a lead network. So when you are going for this lead compensation, there are some applications. The first one is about the bandwidth that will be getting increased. Then it will improve the speed of response. The speed will be getting increased. Then it will reduce the amount of oscillation. What does it mean? When you are seeing, it will be going like this. So these are all the parts we used to call it as an oscillation. So if you want to reduce these type of oscillations, then we can go for lead compensator. Then it will reduce the overshoot. That is like if it goes like this, the overshoot, then this oscillation, those things will be reduced through this lead compensator. And also this lead compensator, we used to call it as an high pass filter. What is the meaning of high pass filter? High pass filter, which is nothing but it will allow only the high frequency signal. That is the reason why this is called high frequency high pass filter. So it amplifies only the high. It will reduce the low signal. And moreover, this lead compensator, the general compensator design GC of S is equal to S plus Z naught divided by S plus PC. So that means this P, which is the representation of poles, and Z, which is the representation of zeros, right? So here when you are looking at the plot, it is an S plane, and here which is zeros, and here it is poles. Okay, so when you are finding the roots of this particular system, compensator GC of S is equal to S plus ZC divide S plus PC. So S plus ZC is 0, then S you will have minus ZC, that is zeros. Then for S equal to minus PC is your poles. So likewise we can able to get the poles and zeros. After getting the poles and zero, that will be plotted in the S omega plane. So here the S plane is an amplitude, and this is your imaginary axis. So whatever the poles you are identifying, if it is zeros or poles, if it is located on the left half of the S plane, then your system has become stable, right? So if the pole is introduced by the compensator is not cancelled by zero in the system, then your lead compensation will increase and the order of the system is also going to increase. So the next one, this is what your lead compensator network. So lead compensator network, your capacitor will be parallel, but in lag compensator that will be in series. So the capacitor is parallel to resistive component. So this is R1, then you have an C component, then R2. EI is input voltage, E naught is your output voltage. So based on voltage divider rule, I already told you in the previous class. So voltage division rule, which is nothing but whatever the signals, whatever the component appear across the output divided by the overall, whatever the component present in the network. So here the output voltage is E naught, the input is EI. So your E naught by EI, which is equal to, the output across the component is here R2, the overall divided by the component which was present in the circuit. But here the capacitor and the resistors are in parallel. So parallel means how will you write? That is 1 by AC into R1 overall divided R1 plus 1 by AC, right? So this value plus the component which was present is R2. So you'll have E naught by EI, which is equal to R2 by R2 plus R1 into 1 by AC overall divided R1 plus 1 by AC. You will get it like this. Okay. Then after that, when you are multiplying the term R1 AC plus 1 by AC, you will have. So finally R2 by R2 of R1 by AC into AC by RC plus 1. So this AC and AC we can get cancelled. So you'll have finally R2 by R2 of R1 of AC plus 1 plus R1 divided by R1 CS plus 1. That means after multiplying the component. So Laplace transform of output by Laplace transform of input is here E naught of S divided by EI of S, which is equal to R2 of R1 into CS plus 1 overall R1 plus R2 of R1 CS plus 1. So here from this particular term, the next step is we have to bring it into the value in S plus 1 form, right? So only because of that we are bringing outside R1, R2 and C. So you'll get R1, R2, C of S plus 1 by R1 into C, right? The overall divided R1 plus R2, R1 CS plus R2. So the next equation is R1 R2 C of S plus 1 by R1 C overall divide R1 plus R1 R2 CS plus R2. So from this particular term, what I am going to do is I am just bringing outside R1 C R2, take it out. So S plus R1 plus R2, you will get like this, right? But because of bringing that particular component into 1 plus form, so I am just taking this particular term as divided by R1C into R2. Okay. So your equation has become the both first and this term R1 R2C is common. So I am just going to getting cancel. So we will have S plus 1 by R1C overall by S plus 1 by R2 by R1 plus R2 of 1 by R1C. Okay. And the general form of lead compensator is the compensator design GC of S, which is equal to S plus 1 by T overall S plus 1 by alpha T. So just to bringing this form, I am just going to make some manipulation. So here this T, which is equal to 1 by R1 into C. What is T? T is time constant. Time constant, which is nothing but resistive and the capacitive component. And the alpha value, which is nothing but R2 by R1 plus R2. So these two things you have to assume. So after making this particular simplification, my expression is going to be E naught of S by EI of S, which is equal to S plus 1 by T overall S plus 1 plus alpha T. Because alpha, which is R2 by R1 plus R2, and T, which is nothing but 1 by R1 into C. So after making this substitution into this final expression, I will get Laplace transform of output E naught of S by EI of S, which is equal to S plus 1 by T, the overall S plus here you can just look at the term 1 by R2 by R1 plus R2 into 1 by R1C. So this 1 by R1C is going to become T, and this term R2 by R1 plus R2 is going to become alpha. So S plus 1 by alpha T. So this is what my final expression of my lead compensator. And for lead compensator, it is also called as an high pass filter, and the advantages of this lead compensator is increasing bandwidth, improving speed of response, reducing the amount of oscillation, then reduced overshoot. So finally I can make the particular system into stable. That means this is my steady state line. If I am going to draw, if my response is going like this, then this is what your oscillation, then overshoot and the steady state, right? But these has to reduce. So finally I'll get the response like this. That means my response is in settling nature. So my unstable system is going to become a stable. So that will done it through my lead compensator. So I can make an unstable system into a stable system. So this is how my lead compensator is working. So this is what my lead compensator network, based on voltage divider rule, you will get this expression. After making into 1 plus S form, I am bringing like this. Then for general compensator design equation, I am just going to compare it. Finally, I can find out the Laplace transform of output by input, and moreover in the S plane domain I have to identify the zeros as well as the poles. So whenever I am going to have the poles and zeros on the left half of the S plane, then my system is going to be stable. Okay, so this is how the lead compensator is working. So I think you would have understand what is compensator, then what is lag network, what is lead network, and how we can design all these things. What is the purpose of controller, purpose of compensator. Yes, I think you would have understand the concept, right? Okay, thank you.